Hi guys, so let's go on to part B of January 2018 CSEC Math paper 2 question number 5. So we have a tank with a cross section with dimensions identical to the polygon EFGHIJ in part A. So if you remember from part A, we found the area of this hexagon EFGHIJ. Right, so let me go back up. We found the area of the hexagon to be 65 square centimeters. So we'll need that information for this part of the question. Okay, so water is poured into the tank at a rate of 75 cubic centimeters per second. After 52 seconds, the tank is 2/5 full. So part 1, determine the capacity of the tank in liters, and that is 3 marks. So we don't need the area of the hexagon just yet in this question. To find the capacity of the tank in liters, we need to use this information here that they gave us. So they told us that water is poured into the tank at a rate of 75 cubic centimeters per second. And after 52 seconds, the tank is 2/5 full. Okay, so that rate of 75 cubic centimeters per second means that in 1 second, there is 75 cubic centimeters of water going into the tank. So therefore, if we find for the volume of water going in the tank after 52 seconds, that should be 75 times 52, 75 times 52, which would give 3,900 cubic centimeters. So this will be the volume of the tank after 52 seconds. And since after 52 seconds the tank is 2/5 full, 2/5 is 40%. So it means that 40% of the tank is full after 52 seconds. So therefore this 3,900 cubic centimeters represents 40% of the volume of the tank. So if 40% represents 3,900 cubic centimeters, then we need to find for the entire volume, which is 100%. So therefore that's 3,900 divided by 40 multiplied by 100. Okay, and that will give us 9,750 cubic centimeters. Now they asked us for the capacity of the tank in liters. So there are 1,000 cubic centimeters in 1 liter. So if we divide by 1,000, right, which means we just have to move our decimal point 3 places to the left. So we get 9.75 liters. So that's the capacity of the tank. Okay, so let's go on to part 2. So part 2 for 2 marks says calculate the height h in meters of the tank. So this is where we need to use the area of the hexagon. Okay, so the height h of the tank is this distance here. So remember, we already have the area of the cross section of the tank, right? Which is the area of the hexagon at the base of the tank, which is from part A, 65 square centimeters. So this is a tank that has a uniform cross section. In other words, if you cut this tank, all right, straight through, the cross section at the end will always be this hexagon shape. So the volume of the tank is the area of the cross section times the height, all right, and that goes for any solid that has a uniform cross section. For example, a cylinder, all right, a prism. Okay, so we use that formula. Volume is equal to cross-sectional area times height. Okay, so we need to find the height. So the height will be the volume divided by the cross-sectional area. So the volume, remember we did that in part 1, the volume of the tank, which was 9,750 cubic centimeters. And we divide that by the area of the cross-section, the area of the hexagon, which we found was 65 square centimeters from part A. So if we divide 9750 divided by 65, we will get the height of the tank to be 150 centimeters. Now they asked us for the height in meters, so we just have to divide by 100. Okay, so just move 2 decimal places to the left, so we get the height of the tank is 1.5 meters. Okay, and that's your 2 marks.